Hi folks, we're going to take a look at number 11 on page 460. Okay, so the question says a spherical balloon is blown up from a diameter of 10 centimeters, so the smaller one here, to a diameter of 30 centimeters, this one here. It says by what factor has its surface area increased? Okay, so remember when we're talking about a factor, we're talking how many times bigger this surface area is to that surface area. Okay, now I'm actually going to do this problem in two ways. Okay, the first thing I'm going to do is I'm just going to actually calculate the two surface areas, and then from there I can find the ratio of the two to determine how many times bigger one is to the other. Okay, so first of all, if the diameter is 10, it means the radius is 5, and here if the diameter is 30, it means the radius is 15. So we need to make sure we're using the correct numbers here. So version 1 would just be to actually calculate the surface areas. So I'll call this the smaller surface area. So it's 4 times pi times 5 squared. Okay, 4 pi r squared. And here 25 times 4 is 100. So it's 100 pi. And I'm going to leave it as an exact answer. There's really no reason for me to estimate it, okay, unless I really need to. So I'm going to leave it like that. Okay, and then the area of the larger sphere, okay, is going to be 4 times pi times its radius squared. Okay, so here, just to take my calculator, probably should do this in my head, but let's see, 15 squared is 225, and then times 4 is equal to 900. Okay, so here we have 900 times pi. Don't forget that we're multiplying that by pi. Okay, and if I want to determine how many times bigger this larger one is to the smaller one, I just divide the larger area by the smaller area. I create a ratio. So I've got 900 pi over 100 pi. Okay, and here the pi's reduce. 900 divided by 1 is just equal to 9. Okay, so that's telling me that the surface area of the larger one is 9 times larger than the surface area of the smaller one. Okay. Now I'm going to do this in a different way. Okay, in fact, this is a more general way because I notice that there's a relationship between these two radii. Okay, this radius here is 3 times the radius of the smaller one. Okay, so I'm going to do this problem so it could work for any two spheres where the radii are have this relationship. Okay, so the smaller radius, I'm going to call that r, and so that means that the larger radius, I'm going to call that 3 times r, which fits this scenario because 15 is 3 times 15. And now I'm going to do the same thing. I have the area of the larger, okay, and I'm going to divide that by the area of the smaller one. And so the area of the larger one is 4 times pi times, okay, this radius here, which is 3r squared, over the area of the smaller one, which is going to be just 4 times pi times r squared. And when I use my, algebra rules here, this becomes 4 pi times 9r squared, okay, because I just distributed the exponent over 4 pi r squared. Okay, here the 4's reduce, the pi's reduce, so I'm just left with 9r squared divided by r squared. Hey, r squared divided by r squared is equal to 1, and so I get 9. So you might sort of say, well, this was more work than that previous one. But the good thing about this second method of showing it is it means anytime the radius is 3 times larger, the surface area is going to be 9 times bigger. Okay, that's it for this one.